Okay, there we go. Hi, so yeah, I'm Courtney Collins. I'm a postdoc at CU Boulder, and I've been part of the leadership team of WISE for a few years now with Michaela and now also with Kendall. And we just had this idea to put together this R workshop series this this spring. And one of the things that people really wanted to learn about R is how to integrate GitHub with R. And so that's where we're at. And I've been using GitHub for my workflow for about the last year and a half as a postdoc, but I'm still new and learning. So hopefully we can, learn together, and I can share what's been working for me. And I do a lot of large data management and also using publicly available data sets in my research. And so I found GitHub to be a really invaluable tool in that regard. So I'm excited to share with you all today. And then we'll have our two moderators and also WISE leadership team members introduce themselves.
Kendall, do you want to go next? Okay, I'll go next. I'm Michaela. I'm also on the WISE leadership team. Courtney and I started WISE with a mentorship program, and our two faculty co-founders, Stephanie Kiblin and Peyton Smith, in 2018. And then we kind of let it languish a little bit when we both started our postdocs. In these pandemic times, we've really tried to revitalize WISE, and we have monthly meet and greets that we'd love to see you at. We have this R workshop series. I'm going to be hosting the last one, which will be April something. I think it's the 18th, maybe. I can paste the registration link in the chat for anyone who's interested when I'm done talking. And that one's going to be thinking about how to organize your code. I use our package structure for all of my projects, and I've been doing that for about a year, and it's been really helpful to me. I also use GitHub pretty frequently. I don't use it that much to collaborate with other folks. I mostly use it to collaborate with myself and try to keep track of what I have going on. I'm a postdoc with the USGS in Moab, Utah. I work with Sasha Reed here. My background is in plant-soil interactions. I did a lot of microbial ecology, mycorrhizal work in my PhD. And now I'm working on a whole bunch of different stuff. I'm doing some biocrust stuff, and I really like working on questions that are motivated by challenges in land management. So I work a lot with regional land managers. And that's pretty much it.
Hey everyone, I'm Kendall Beals. I joined the WISE leadership team in the fall, and I'm a PhD candidate at the University of Tennessee. I work on plant-soil microbial interactions in natural systems, and this is kind of my first GitHub workshop. I'm very new to GitHub, and so I'll be learning along with all of you, but Michaela and I are kind of going to be monitoring the chat and things like that. So Michaela will probably be answering more of your GitHub questions and that sort of thing. But yeah, excited to get to see how this workshop goes. And just like Courtney and Michaela said, if you are in soil science in any way and you want to be involved in our network, we are very interested in having you. So definitely you can send us an email or reach out to us on Twitter or anything like that.
Yeah, and so for the format of the workshop, I'll go over the outline of what we're gonna do. But for questions, if you have questions, feel free to just, ask and even interrupt me. That's fine if something is just, you're stuck on something. Or if you'd prefer, you can put the question in the chat, and then Michaela and Kendall will either answer it for you in the chat, or they can just stop me and let me know. And we also have kind of time built in for questions in each of the sections that we'll be doing. So yeah, and if if you're willing, again, I know I already said this, but if you're willing to turn on your camera, I'd love to see your faces. I find that it's helpful to see if I'm getting nods or people look confused, and kind of just get that feedback as well. So if you are willing. Yeah, so I think we can probably go ahead and get started. And a lot of this is going to be us working together. So live coding, but not as much coding, more kind of moving through the RStudio interface and GitHub interfaces. So I'd like this to be interactive where you all are working on the same thing in parallel with me. Hi, Mia. All right, so I'll go over and has everyone filled out the survey? Awesome. If you have not filled out the pre-workshop survey, go ahead and do that right now. Michaela, do you want to just put it in the chat again for anyone who joined after you dropped that link?
Yeah, I can definitely do that.
Awesome.
It's only like 4 questions.
Yeah, it should only take you a minute or two. If you would fill that out, that would be awesome. All right, cool. So I'm going to share my screen and I'll go over the outline. So here we are with our GitHub workshop. And basically, well, we just did our introductions and our survey. So part 1 is going to be about an hour. I'll do an overview of GitHub and what it is and why we might want to use it, different ways to interface with GitHub, and also the online interface profile, kind of what that looks like and why you might want to use that and when. Then we'll go into GitHub and RStudio and how to use the RStudio interface with GitHub to track changes to R scripts and code, but also to entire projects that you're working on. We'll talk about the different sections of the RStudio interface.
Courtney, I don't think we can see your screen. I guess it's just on mine. It says
mine says the same. Yeah, mine says Courtney has started screen sharing, but I thought maybe it was just my computer because my computer sucks sometimes.
Oh no.
Can you stop screen sharing and then try it again?
Yes. Can you see this now?
Yeah, we can see it now.
Okay, sorry about that. All right, so here's our overview, and I can just drop the link to this too if you all want to follow along. Looks like you did not forget to record, so I'll take that out. I'll drop this in the chat in a second. We'll talk about the other parts of the RStudio interface and kind of what are the core components, and then what are some of the kind of extra components that you might want to use but don't always use. Then we'll take a break, get some coffee, whatever you need to do, and come back and do part 2, where we'll focus on working in a shared repository. So how we might use GitHub and shared version control projects to work with others and to collaborate with others on script and also on projects in general. And kind of how you might need to think about it differently from if you're just using it to track your own work. We'll talk about things like issues and assignments, merge conflicts, and reverting to previous commits. And then finally, I'd like to give people time to move over an existing project that they're working on. Maybe they're working on it from their desktop or Google Drive or something like this, and give people time to actually get something set up in their own GitHub interface so that they can start, you all can start just now working with version control on something you're already doing. So hopefully that will be more useful than just having a test repository that doesn't really mean much to you. And if there's extra time, there's some other activity prompts that we can practice skills, or people can use time kind of as they need. We might not go for the whole 3 hours, but I'm happy to stay if people have questions and want feedback on stuff. So yeah. We can go ahead and get started. Has everyone, sorry, I already asked, but Could everyone give me a thumbs up if they filled out the survey?
We have 13 responses, so it seems like almost everybody did it, which
Okay.
is great.
Awesome. And I need to get back to my main Zoom window because I can't access the chat for some reason. Sorry, okay. Here is this link to our outline if you want to kind of follow along with where we're at, but you don't have to. Okay, so. All right, so GitHub, what is it? What is Git? I did not know this. I did not understand this just about a year and a half ago or 2 years ago. So I'm right there with you. So can you see when I change screens? Okay.
Yes, you can.
So Git is a free and open source version control system. Git is a software, right? So you install Git, this software, on your computer, and it allows you to do version control with your own work and your projects. Basically, it's allowing you to track the exact time and all of the changes that you make in a file over time. According to this website, Git is easy to learn and has a tiny footprint with lightning fast performance. So Git is the background that's working, whereas GitHub, which making this distinction wasn't always clear to me, GitHub is our online interface that allows us to track these changes that Git is making. Or Git's not making the changes, we're making the changes, Git's keeping track of the changes. So GitHub is a way to interface with Git. GitHub is the most common way to interface with Git, but there are other ways to interface with Git, like GitLab, Gitbucket, a couple other Git things that I don't really know about. So we're going to be focusing on GitHub today. And the difference between something like Git and GitHub and say Google Drive is that, which a lot of people probably use Google Drive and Google Drive Sync, which I do too. However, Google Drive and these types of cloud-based things they're saving your work immediately, right? They're just saving the newest version and they're overriding the previous version. Whereas Git is tracking all of the changes in each version and it's not automatically doing it. You are telling Git and GitHub when you want to push, when you want to save that new change, when you want to track that new version. It's kind of like saving a new version of a Word file, like Courtney's abstract v1, Courtney's abstract v1.1. But we all know that's really tedious. And so instead of doing that, Git is doing that for us online in GitHub. Do people have questions about that? Just kind of conceptually? Okay, cool. So why use it? And I think everyone has their own thoughts on why to use it. But I like this motivation description here. Can you all see this? Okay, great. So, and especially using GitHub with R is really powerful because Git was really intended to track changes in script and coding files. It was really developed for software developers and programmers who are making a lot of changes to their scripts, but we are also making a lot of changes iteratively to our coding scripts. And so Git will track changes in any type of document, but it really shines within coding and script documents. And so with R, it's really making your research reproducible. And this reproducible research idea is really becoming important and popular in the sciences. And I think more and more journals are pushing for this. pushing for access to code when you publish papers, pushing for access to not just like a CSV with the raw data, like they want more than that, especially some of these higher impact journals. And so this is really going to set you up to be able to do that easily and efficiently. It makes your sharing of your projects easy. So once it's set up, you will get there, and it facilitates collaboration. Like I said, you can use it to collaborate with yourself and kind of keep track of your work, but you can also use it to collaborate with other people. It's much easier than sending an email with a CSV of a bunch of data and an R script that has maybe the wrong addresses, or maybe the working directory doesn't work because it's set to your machine, and then you send the R script to someone and they can't make your code work. Git allows you to structure something so that someone else can just pull down your project and start working on it, and then go back and save it to a shared working folder, if that makes sense. And so you can also revert back to previous versions, which we'll do today. If you find errors or accidentally deleted stuff, you can go back in time and revert the changes that you've made. You can also look back in time and see maybe 6 months ago what you did. And this has been really helpful for me, especially writing a paper recently and trying to think about writing the methods of my models. I was trying to remember when or if I made a certain change to a script that I had written to pull in climate data. And I could not remember, I didn't have it anywhere in my notes. And I went back to my GitHub log and I scrolled back, months and months, and it was there. I had told myself what I had done. And it was really great to see, one, that I had done it because I was freaking out that maybe I had forgotten, and two, what exactly I had done. And so that's something super powerful about Git. It really forces you to keep track of your work and gives you that permanent log. It also makes sharing of your packages easy, and there is a really nice interface with our packages, which Michaela will go over in April. So a little teaser for that. But that's kind of like, once you've got this going, that's the next layer of being even more efficient with your code. Yeah, so again, you can see here, GitHub is user-friendly web service that allows you to store your project repository remotely. GitLab and Bitbucket are also alternatives. But RStudio integrates support for Git, which is a widely used combination, which is what we're going to go over today, and which is how I interface primarily with Git. So, any questions on that? Everybody with me? Okay, great. So hopefully everyone got to make a GitHub profile. And we will go over the profile online interface. But if you would pull up your own profile, that would be awesome. So you can kind of look at it while we're going through mine and kind of see where you might find these different important things in your profile. Can everybody see this? Okay, great. So,
yeah, Courtney, your profile looks awesome.
Thanks. All right, let me pull. All right, so we want to go over profile, presentation. So here's your lovely GitHub profile. You all maybe already had one, or maybe you made a new one for this workshop. Does anyone not have a GitHub profile or registered? If you don't, you definitely will need to. So go ahead and do that now if you have not yet. So kind of our overview here, we can see the different repositories that, that I'm working in. And a repository is kind of a term for a specific project that you're tracking in GitHub. And so a repository will have your scripts and your data and maybe output files that you have made from whatever code that you've run. Also, a nice thing about repositories is you can kind of leave descriptions for them. And so you can see for my descriptions and my README for some of these repositories, these are actually describing the papers that they go through. And so this is allowing for when I write a data availability statement in a manuscript, I just put the link to this repository. And then anyone who reads the paper can go and open this repository and clone it, and they can reproduce all of the scripts and all of the analyses for that paper. They can even remake all of my figures if they want. And so that's kind of I feel like that's the standard that people are wanting to get to now with reproducible research, and GitHub makes that super easy and available. So these are repositories. Does anyone have a question about repositories? Okay.
I do. Sorry, if I can ask a question about repositories.
Yes.
Can you have repositories within repositories, like subfolders, or does that get really complicated really fast?
Yeah, so repository within repository is not something you want to do. That makes Git really confused, but you can have folders within. Like I have my data folder here, I have scripts folders, I have, right? And so a repository is kind of the same as are you seeing this? I have data, figures, scripts.
Yeah, you can see it.
Yep, that's great. That's
So
helpful.
it's really the same setup as something you would set up on your local machine, and you will have a version of this on your local machine as well.
I often think of it as like a mirror of what I have on my local machine. Mia, did you have a question?
Awesome.
Yeah. Hi, Courtney. I'm curious where you have HTML on some of the repositories and R on some of the other ones. Is it because you used GitHub Desktop or the online version of GitHub for the one for WISE?
Yeah, so most of my repositories are using R, and I have more repositories, but some of them are private. So only your public ones are going to show up here. That's another thing to know. So for the HTML one, this is actually a repository that runs our website. And so if you were to pull this code down to your machine and then, but please don't, and then make changes, that will
change our website.
That's how we change our website. That's how we run our One Page Wonder Women in Soil Ecology, which you can see is hosted at a github.io. And so that's another way that you can use GitHub. That's why it's HTML, because it's just making an HTML output. Does that make sense?
We have another really good question. Can you define the difference between a repository and a folder?
Yeah, I mean, no. I think that repository is GitHub's name for a bunch of folders together.
Yeah, I think I would define your repository as like, you know, you have your different projects on GitHub and your repository is each of those projects. And then you'll have folders within the project that are your scripts and your outputs, those types of things. Yeah. So like on my GitHub, I have, for each of my dissertation chapters, I had a GitHub repo. For each of my postdoc projects, I have a GitHub repo.
Repo equals repository. If you want to have the cool GitHub lingo, people will call them repos a lot. So just know that. Yeah, that's a great way to put it. So a repository is thinking about something in terms of like a project. So this is like maybe one chapter or one manuscript or one kind of collaborative working synthesis group. Does that make sense? And I try to keep my repository structures really similar across. So I always have a data folder where I have raw data. I always have a scripts folder where I have all the scripts. And then when I'm using one for a published manuscript, I usually have my supplemental materials and figures as well. But you can have your repository structure be anything you want. I just find that when you're sharing with different people, having your folders within your repository be named in a really intuitive way is super helpful. Any other questions? And we'll go over how to get your repositories on your GitHub online onto your local machine and what that looks like. We will definitely do that. Okay, and so the other fun thing about GitHub online is the contributions tab, which makes me happy. And you can also see kind of when I'm not coding, right? So like November to December was like the holidays, but also I was doing a lot of job applications. So like I really wasn't putting much on GitHub then. I wasn't coding much, but you can see I was doing stuff yesterday. So prepping for this workshop. So it's kind of fun. You can look at it for yourself and just kind of see your productivity and what you're doing. Also, other people can see what you've done, and it can be a great thing for jobs when you're applying for jobs and trying to really highlight your data skills and your kind of GitHub skills. People can look and say, oh yeah, this person uses this. They're not just saying it. So that's cool as well. And then if you were to click on any of these, you can see all of the contributions that you made on that particular day, which is like, to me, just kind of amazing. So I did this thing on September 13th of last year, you know, and then I can even go to these changes that were made like during that time and see exactly like what my world looked like at that time. And we'll get into that more, but okay, so any other questions on activity contribution, profile, repositories, kind of the online GitHub interface? So that's github.com that we just looked at. Github.com is, well, it's a way obviously to store all of your repositories and you need it, but you can also make changes directly through github.com, but we're not going to go over that today, but you can, everything that we're going to do in the R Studio interface, you could also just do directly on your GitHub website. So that kind of brings us to this step, to this part D. So there's so many different ways that you can interface with Git and GitHub. So you can do it through the command line, which a lot of people do. Michaela does. You can use GUIs like GitHub Desktop, which some people use. I don't have GitHub Desktop, but some people like it and use it. You can make these changes on github.com, which I can actually just go to something and just show you what that would look like here, right? So if we were to want to make any changes, I'm not going to do that, but right, we could change, we could just literally edit our files directly here. And then we can commit these changes and push and pull them. So I can edit my R code on github.com if I want to. I don't usually, but sometimes I do. And then finally, the way you can interface with Git and GitHub is through RStudio. And that's the way I do it most often because I'm working in R and that's where I want to track my changes. And in order to do that, we need to use the R projects structure. So how many people here have used R projects in general before? A few people. Okay, cool. Yay. And so to clarify, our projects are bigger than GitHub. GitHub is bigger than our projects, right? They're not one and the same. You can have an R project that's not tracked using GitHub, and many of you might have that. But in order to use the RStudio interface with GitHub, we have to use our projects. It's just the way that Hadley or whoever decided to make them talk to each other. And so that's kind of bring us to our next step. And are there other questions? I just saw stuff pop up in the chat. Do you usually use a regular R script or R Markdown, etc., to interface with Git? I usually just use so to interface with Git, you're using R projects, right? So you're saving all of your scripts and anything else in an R project in your folder.
Does everyone understand what an R project is? Is that, yes?
If you don't, we will make one together in the next step. Sharon, did you have a question?
I just was hoping can one of you say a sentence like an R project is yada yada?
Do you want me to?
Yeah.
Yeah. So in R project, basically you can open R in RStudio and just make independent scripts and save them wherever, which is how I used to do it when I first started, which is a mess. Like you end up being really confused. So in R project, basically when you open that project, it sets your working directory. So it like brings you to the place where all your data is. And it's a way to keep all of your scripts for one project together. And in next month's workshop, we'll talk about kind of the next step on that, which is making it into a package, and a package is a project. Just like if you were to ever use ggplot, that's a package, but you can make your work into a packet in the package structure. And maybe you wouldn't put it up for other people to use, but it's a way that if you were to make functions or other things like that, they load automatically when you open that package for one particular research project.
Right, and so an R project, again, is just a way to kind of save a lot of different scripts and data at the same time. And it's kind of similar to a repository, and it's like, that's the project you're working on. These are the moving pieces that go together for these particular analyses or questions. And you kind of define what goes into that. And about R Markdown, you can use R Markdown scripts in GitHub version control. There's something called Git flavored R Markdown, which I don't totally use or know. GFM, if you want to know the acronyms. But you can do either, to the question that was asked about R scripts or R Markdown. Any other questions?
I have a lot of repositories that have both scripts and markdown files. I have ones that have R presentations in them. So you can really mix files within your repository, because GitHub is mostly just a way to back up. It's like almost like backing up your work that you're doing locally. I think of it like that.
Yeah. And just also to be clear, like just because we are using RStudio to interface with Git and GitHub does not mean that we're only able to save or track changes to R files. Git will and GitHub will save and track changes to any files. So your Excel files, your Word documents, everything, they will all show up in your RStudio Git interface as long as they're in your R project. Does that kind of clarify a little bit? And we'll go through some examples. So people ready to get started and kind of work together on some stuff? Awesome. Okay, so we are going to work through kind of step 2 of the reproducible research tutorial that I sent you all about how to, so you all did the installation and setup. And so now we will move to the create a new RStudio project with Git. Okay, so kind of like what we talked about, there are many ways to interface with Git and GitHub. We will be doing the third version here. So we will be creating a new project on a remote Git repository. And we can start that now. Okay, so we're gonna create a new repository. So if everyone can go to their GitHub page.
Courtney, do you maybe want to post this URL in the chat, and so then people can?
Yes. I keep kind of losing the chat though with my screen. There it is. Okay. Here we go. All right, so we are on part 2. No, that is not what I want to share. I'm sorry. All right, so we are going to make a new repository together. I'll make
It's doing
one.
the thing where we can't see your screen and it just says that you've started screen sharing. Oh, wait, now I can see a white bar.
That's weird. Okay. Good.
Yes.
Okay. So here we are in our github.com profile, which we went through. So first thing we're going to do is everybody on their respective profiles. Awesome. So we're going to click on repositories. And you can see your repositories if you have any. You're going to click new. We are going to make a new repository. And you can name it whatever you like. So I'm going to name it very creatively, like Wise GitHub Workshop or something like that. And my name is available, so that's great. So if you name it Wise GitHub Workshop, it might not be available. And I'm going to say this is a test repo for the GitHub Workshop. You can write whatever description you want. You can name it something funny. We're going to delete it. And we'll go over how to switch public and private, so it doesn't really matter which you select, but let's keep it public for now. But we'll go back and talk about how to change those settings. And then initialize its repository. I always like to add a README because it's kind of a description of your project, especially when I use this for reproducible research from a manuscript. I usually have a README that tells whoever is interfacing with my repository what all of the folders have in them and what they do and kind of how the scripts work together. And I usually describe that in my README. README is just a text file.
It's definitely best practices. And for me, when I'm collaborating with someone, if they send me something with a README, I'm like, okay, we're on the same page with how we want things organized.
And READMEs are nice too, even for yourself. So you can keep track of what's going on. Gitignore is also going to be your friend, especially when you are collaborating with other people. There's going to be some stuff that you don't want Git to be tracking changes on. You really don't want to be pushing and pulling from your online Git interface. You don't want to be pushing and pulling huge data files. Those things will probably want to stay on your local machine. And so we'll talk about how to get that into a Gitignore. And very nice is that you can choose what kind of Gitignore template you want. So I will always choose R because I'm doing things mostly in R. And then that will kind of populate a Gitignore for a lot of common things that our users will want to put in their Gitignore. Cool, everybody here? So we'll create our repository. And now we have a beautiful new repository. So we have our Gitignore file and our README. And the README shows up here. Right, this is our README. That's how all of the repositories use the README. If you go back to your main project, now you can see, if you click on repositories, it's here at the top. Everybody have a new repository?
Can you describe, Courtney, the term commit? what that means? I mean, I think we'll get to it, but you've been saying it a few times.
Yeah, we'll definitely get to it, but commit is when you're making changes in a file in your repository and you want to describe the changes that you made before you push those changes up to GitHub. And we'll go through that as well. But it's kind of a way to tell Git, okay, this is the change that I made at this increment, and I'm going to save that change. That's what a commit is. Kind of like you're committing to this change that you've made in your document, in your script. That's how I think about it. But we'll work on that together in our new workshop repository that we've created. Okay, so now let's get this into RStudio. So we are going to click on this code button here. And we see the term clone. This is an important term as well. So clone is a way to copy an entire repository and all of its contents onto your local machine, right? And so when I say your local machine, I mean your laptop, whatever you are working with, that is yours, and it is not the same as what's on GitHub.
And I think sometimes like if I'm working with an R package and there's some weird bug in it and it's like, this thing doesn't work, sometimes I'll go to the GitHub page and I'll clone it and I'll just edit it so that I can make the function work that I need. So I think often you'll use clone, especially if something's in development and you want to use it. It's a good way to get a copy of it on your computer.
So you can clone your own stuff to get it into your RStudio interface, which is what we'll do today. But you can also clone anyone's public repository on all of GitHub, right? So if I want to go and clone Jim Clark's scripts for his new model, which I just did, I can go clone that whole repository and put it on my local machine. And then I have all of his scripts in working directory too. I can't edit them. There is a way to do that, which we can briefly talk about, but I can have them on my machine in the same structure. Yeah, Sharon.
Sorry to ask so many questions.
No, it's okay.
When you clone something and pull it down to your local machine, do you usually do that for your own work, when you're cloning your own work? You would do that maybe if you have a ton of changes to make in your code, but you might not bother to clone it and pull it down. If you know that there's like an error and you just have to change a typo in a line, you would only go in and do that directly on GitHub. Is that accurate?
No, not quite. So clone and pull, those are going to be separate things. So clone is what you do at the very beginning when you want to just get the structure onto your local machine. And so usually you're only cloning once. Pulling, you're making iterative changes and you're pulling those changes down, and then you're pulling whatever is on the github.com down onto your local machine, and then you're pushing changes that you make back up. And so that's actually really useful when you're working with other people.
Yeah, I think you usually only I only usually clone things that belong to other people, or if I've like made some catastrophic mistakes on my copy of my project on my local computer of my repo, and I'm like, oh no, I ruined everything, nothing works, and I want to go back to my old version, sometimes I'll clone it, but that's not the most agile way, and I'm sure Courtney will talk about that.
Yeah, we'll go through that too at the end. But in order, yes, you will clone other people's work if you want, but in order to interface with RStudio, you do have to clone every time. This is how you start. You make something on github.com, clone it to your local machine through RStudio, and we're going to do that right now. Hannah?
Hi, yeah, just wanted to ask a really quick question. So, and this might be something we get to eventually, but is cloning similar to forking a page, or is that like totally a different process?
Yeah, so forking and branching are different processes, and they have a little bit of different properties. I'm not going to get into them too much today because forking and branching are kind of how you would work on a project in parallel to a project, and it's a little bit more complicated. I don't actually fork stuff at all, but other people can also fork your work, and then they can ask you, someone could fork your repository, make changes, and then make a pull request and ask you if you want to incorporate those changes. And you can say yes or no. That's kind of what forking is going to do. But we're not going to get too much into that because it's kind of a little bit more advanced. So, okay, so we're going to clone this repo down to our machine. So here's our HTTP. So we're going to copy this link. This button will copy it, or you can just copy it, right? Maybe. Maybe you can just copy it. Okay, so copy this. All right, and let's get to our studio. Okay, here we are. So we're gonna tell our studio that we want to, is everyone in our studio? So you're on a file, new project. This is where the R projects come in. So we're making an R project. Don't want that. But we're making an R project with version control. And some of you already did this yesterday just to check that your Git was working. So click on version control and you'll see Git. Now you have Git as an option for version control in your R projects. And now here's where we put this link that we copied from online. So paste that in there. You have a project directory name. It's the same name as what you made on the website. And this is important. You want to tell our studio Git where you want this project on your local machine. So for me, it's in my documents in a folder called Git. All of my R projects are in that folder. And I would recommend keeping them all in the same location on your local machine. These are all of my Git repositories. But this could be called anything. This doesn't have to be called Git. I called it Git, but this is your local machine, right? This could be on your desktop.
So I have a question, Courtney.
Yes.
The way that I organize my files is that I have, like on my local computer, I have different projects, like different chapters of my disk that are just in their own separate folders. And so I have my R projects within those. Is there a particular advantage to having like a Git folder and just having all of the Git repositories in there? I'm just wondering, like, yeah, what's the best way to maybe like organize your local computer, or are there particular disadvantages for ways to like not organize it?
I keep all of my version controlled stuff in the same location. Just, I guess, because that's sort of how my brain works. But if you, yeah, we are using our project, so it will go to the same spot of wherever that R project is. But when you're cloning a new repository, you can change the location. So if you don't want them all to be in the same place, they don't have to. But mine always goes to the same place just because I don't change I don't change this. Like, that's what our studio knows where to put my stuff. So yeah, I don't have a great answer, Kendall, but yeah.
So basically you just have to make sure that like that, where your cursor is, like the subdirectories, you're always like specifying where you want that.
Yeah.
I've got a question. So I use a lot of Dropbox. So this subdirectory needs to be in our local computer, or I can save it, let's say, in my Dropbox folder that I have on my computer.
Yeah, I wouldn't save stuff onto Dropbox or Google Drive. I would be saving stuff onto your local machine. Yes.
I think you can think of your GitHub stuff as sort of your Google Drive Dropbox of your code, because it
is
will
now-
back things up.
Yeah. Git is now your Dropbox. Git is now your Google Drive, right? Hopefully that this will convince you that this is maybe a superior type of version control option. Yeah.
You can even work on, like if you, in terms of Kendall's question, you could even work on manuscripts on GitHub. I've never done that before, but I know people that have kind of had their entire workflow just on GitHub, and their collaborators go and pull it down and make edits to the manuscript and push it back up.
All right, cool. So we are going to create this project. Everybody there? And so now you can see that it's cloning. So you got a little box that said cloning into, and that's what that means, right? So it's making this our project. And now we can see here on the top right of our screen that we have our R project, and this is called Wise GitHub Workshop. Is everybody there? Everybody have RStudio doing this for them? Cool. Okay, awesome. And now we will also see this Get tab that a lot of people were looking for yesterday. And unfortunately, the tutorial was a little confusing, but we can see this Get tab shows up, right? Now we see that we have an R project in this Git folder. You can also see Git right here. And these are all of our Git options here, and we'll go through them. So any questions at this point? So we have an R project. It's being tracked through Git and GitHub, and it's in our RStudio interface. And it's on our local machine. So we are going to go to, right now it's here. Like it made a folder on my local machine.
Courtney, we're still just seeing the RStudio screen.
Sorry. I hate that part about Zoom. Right, so now here I am in my file explorer. I have this new folder called Wise GitHub Workshop that was made at 10:56 a.m. Mountain Time. Does everybody have that? Cool. All right, so let's play around with our new repo. And let me get back to this. Okay, so here we are with our new repo. And let me also get back to my Google document. Okay, so we have created an RStudio project with Git. We have created a new repository and cloned the repository. And so now we have our local repository, right? So we have this folder that's on our local machine, which I just showed you all in my file explorer. And we also have a mirror image of that on our github.com profile. And that is what we cloned from, right? And so that's the difference between your local repository and your global repository or just your GitHub repository. People call it different things. And so we will now make an R script. So let's create a new file. Let's create an R script. And let's say in this R script, we're not really actually going to do anything, but we're going to write some comments. And if everyone could do this too on their machine, and so you can kind of go along with me. Right, whatever you want in here. Is everyone doing that? Cool.
We got a question in the chat from Mia that says, my global environment is empty. Should I browse?
My
It looks
global-
different than yours. I don't know if, let's see, yours has Wise GitHub Workshop, our project. I went through the process with you, and I have on my local machine the repo in the location. But when I look in my top right quadrant, oh, okay, I need to have the Git.
Yeah, if you're on the environment tab, it will probably be blank because you shouldn't have, unless you were doing other stuff, you shouldn't have anything loaded in your environment.
Perfect. Yeah, I did a new project. I see it now. Thank you. And my apologies while I stumble through this.
No worries. Yeah, that's
We all stumble.
yeah. Your environment will be blank because yeah, this is brand new. There's nothing in here. But if we were to load some data or whatever, that will show up in your environment just like normal R Studio. But on your Git tab, you will see this new R project. So and you will now see this new amazing R script that you just created. And this is going to be called test, very creatively, or whatever you want to name it. And voila, we now have test.r showing up in our stage screen. Okay, is everyone seeing this? So this is your first kind of like tracked change that you've made in your GitHub repository. So staged. Staged means you have made a change to a file and you have saved it on your local machine. And it has popped up in your little Git tab. That's something that's staged. When you click a staged thing, you will see this little icon here. It will tell you what was done. These icons are actually really informative. So A is for added. So Git is telling you that you just added this new amazing script called test.r. Another thing that you will do often, and most often you will see, is it's not going to be as fun. So I'm going to take away some of these exclamation points and we can see that it's changed, right? We see that the R script changed, which you can see by the little blue. I'm going to save that again. Now I also have a modification on my test script. So it was added, but it was also modified, which is this M. Although now it's just saying A, but it's because I didn't push it. Actually, I should have committed it when I added it. Okay, I've still just added it. I haven't committed it. So we'll commit it now. So we have clicked.
And Courtney, does that mean that it's not, it's not on your, because you haven't committed it yet, it's just on your local machine. It hasn't been put online, right?
It's not in your Git history yet. Exactly. So we'll press this commit button. Okay, so we'll commit our test script. And
quick question.
Yes.
When you commit that test script, do you have to have test.r highlighted in your Git tab to do that?
Yes, in the RStudio interface, you need to click the staged little check.
Okay.
That's how you tell RStudio that you want to do that. If you didn't do that, if I didn't click it and I just did commit, it's going to say, I don't know what to commit. And I do this all the time on accident. But, right.
But if you work in the command line, it'll just do everything that's changed. And we're not going to get into that stuff today, but that is one difference.
I do like that part about the RStudio interface is that you can separate these out and decide which things you want to commit separately. And so now we're also getting into the really awesome thing that Git does, which is this diff pane. And so diff is for difference. And diff is going to show you exactly what's different between this version and the previous version. And so things in green are things that were added and things in red are things that were taken out. And so right now we only see green because only this stuff was added. This is a brand new file. But if I were to save it and yep.
I'm not sure I'm following. Sorry to interrupt. I don't see text in green. I don't know if we're not seeing your whole screen. I know that I hit commit on my screen and then another window popped up.
Yep.
I'm not seeing another window.
Yeah, we just still see your RStudio.
Oh, bummer.
window.
That's probably like the saving or the sharing problem with.
I think there's a share option in Zoom where you can, rather than share a specific window or application, you can share everything that you're, like every time you switch around, you can.
Oh, really?
Mm-hmm.
Could someone
just
tell
share your whole desktop?
Could you tell
When
me
you open
that?
Well, if you stop sharing your screen and then when you press share screen, just click the desktop one instead of one. When you click like one screen, it gets weird. At least that's what I found.
Ah, I'm sorry. Portion of screen. Okay. Sorry. I understand GitHub, but I don't understand Zoom. So do I just click screen one or what? Sorry.
Desktop. If you open share screen, it should, oh wait, I have 3 desktops.
Yeah.
Just pick the one that has your Zoom screen on it, like desktop 1.
Okay. Is this working?
Now we can see it, yeah.
Yep.
I think
Thank
us postdocs actually don't Zoom as much as everyone teaching online.
Oh man, okay, thank you so much. All right, so here we go. Can people see this now? Test.r. Amazing, this will help for our next few hours. Okay, so we're gonna make a commit message, and this is where we're telling Git and also ourselves and anyone else we're working with what was done. So what was done? Added test script for workshop. But normally you would write something like changed data to means instead of medians, or you would write about what you're doing in your R script in your analysis, right? Or like added analysis script to run an ANOVA, whatever. You want to write something descriptive that you're going to remember, and it's going to help you and your collaborators know what changed. Okay, so does everybody have their commit message? So we're going to press commit. And we'll see here that one file changed and there were 2 insertions, and those were the 2 lines that I wrote. And everything worked. So we're going to close it. And so now we have a commit, right? So we've committed these changes. They're in our R history, but they're not yet on our they're not yet on our github.com interface. That is what we have to do next, which is push, right? And so when you're working with other people on a project, you always want to pull before you push. Pulling will say, okay, whatever is on that global repository on github.com, I'm going to pull those changes down and make sure that those are synced and up to date with my local repository. And then any changes I make, I'll push up. So we'll pull, it'll tell us everything's up to date because no one else is doing anything in this. Or maybe it's just gonna hang. Sometimes this happens.
Courtney, is this something that we should do before like making changes? I'm sorry if that's like a really basic question, but
no. Yes.
Like if you're working with someone else, should you pull before you even start to commit changes?
Yes.
Or like not even commit, sorry, wrong word, before you start to like change things in your script?
Yes, that's my recommendation. Pull often and pull before you make a lot of changes because, and clearly Git doesn't want me to pull right now. I'm not really sure what's going on. But before you get halfway through changing an analysis script, maybe it's because I haven't actually ever pushed anything yet. Before you get halfway down an analysis script and you realize that your collaborator also made changes, and then you're gonna have a merge conflict, which we'll go over later. Pull that first, see what those changes they made, and then start making edits.
Yeah, I think that's a great question. You don't have to pull things. So if you're just working alone, then like hopefully no weird gremlin has come in and changed all of your scripts. But when for the WISE website, we take turns working on it. And the first thing that you always do when you switch to have your turn is you pull down everything so that you have the most up-to-date website and you're not working off your version from a few weeks ago.
All right, so I don't know why my poll's not working, but let's push.
Can I ask a question for a minute? I think I'm a little confused about where things are being stored. I feel like if you're going to pull something, then it's being stored on like the Git repo, and you're like, would you be overwriting something that you already changed? I'm feeling a little confused about sort of where things are stored and what versions are getting overwritten.
Yeah, so nothing's getting overwritten. That's the other part about GitHub. It's saving a version every time you make a new change. So you have an iterative log of every version that's ever been made. But your newest version will be kind of active, and that will be on your github.com account. And then when you pull, that will sync everything down to your local machine as well. Does that make a little more sense? For some reason, I am not able to push and pull right now. I don't know why, so I'm gonna try closing out my project. Are other people able to push and pull?
It looks like some other folks are having that issue as well. So Kaylin said the push was taking a really long time.
Yeah.
Huh.
Mine worked fine. But I do have a quick question. It asked me to put my username and my password in. Is that something that you have to do every time?
No, it's not something you do every time, but it will ask you maybe the first time you do it. Yes.
Thanks.
Let's try to get back here.
If you have multiple GitHub accounts that you work on too, it will ask you for password, but I would recommend not having multiple accounts if you can avoid it.
And if you use the command line in a super or cluster and you want to interface with your GitHub, it will usually ask you for your password. So know your GitHub password. Another cool thing about GitHub and RStudio is it's going to tell you that your branch is ahead of main by 1 commit or 2 commits or 10 commits. And does anybody want to take a stab at what that means and why that's valuable? Just kind of see if people are following this logically.
I think I just did what you asked us to in the chat. At least this is my conception. Like commit is like a trial run push. And before you really commit, you pull to make sure somebody else isn't working on the WISE website against your protocol. And make sure there's no conflict there between the versions. And if that's true, then you push.
Yeah.
Is that accurate?
Yeah, that's
So
a good.
Commit's kind of like a misnomer. Like commit sounds final.
and your commit is your opportunity to leave yourself a message or your collaborator a message, and that's really important because so when you write the commit, you'll be changed this figure this way, or changed change this type of analysis, and that way both you and your collaborators can see what you actually did.
Mm-hmm. And a commit is your last chance to bail out before you, which again, Sharon, I like, but commit's not a great term. It's your last chance to kind of bail out before you push things formally to your github.com.
You're walking down the altar, but you're not there yet.
Totally. Okay, so we'll see. Can I push in this R workshop? That would be in this GitHub R workshop. That would be amazing. If I can't, I'm gonna be frustrated. I did this like 4 times yesterday. Don't know why my machine is not happy with me. Okay. This is great. All right.
Well, while we're waiting for that, Courtney, sorry, I have a question.
Yes.
So when you're doing the commits, I'm just trying to think of like, imagine if I were working on a script with someone and we're both updating it. So it sounds like commits need to be made for like every change that you're making. I mean, what if you're just, you know, someone misspelled something in annotation? I mean, do you need to commit that? That sounds like something really trivial. Or that just show up like in the
yeah. I would make commits anytime and write a commit message anytime you're changing something that functionally alters the script. So maybe you're adding a new component of a new model, or maybe you're changing the priors on the model, or maybe you're adding script to make a figure. Something that's like a functional change is usually when I make a commit. I wouldn't normally make a commit just to like, just for typos, but you know, it's also up to you. You can commit often and push less often, right? Like you can commit multiple times and then push all of them at once, unless you're me and you can't push anything.
I often will do multiple commits before I push, just because I like to, depending on what I'm working on, I like to have a lot of commits as my almost journal of what I've been doing, because I'm very forgetful.
So Michaela, does that mean in the comment box for the commit, are you kind of writing notes to yourself, like
Yes.
to remind yourself what you did last week?
Yes, I'll write like, reran these models, I changed these things, remade this figure. And sometimes I'll even write, remade this figure, need to do this next. Because I find that I'll be working on something really intensely and then I put it down and I have to go to my rest of my work life. And then I come back and I'm like, who was this person? What was she doing?
I am sorry about this. Is this maybe because, all right, so like I'm gonna commit my R project. Just don't know why it doesn't want to push and pull for me. Have other people been able? Okay, there we go. I think it was because I didn't have my R project pushed in there, but that's another story. Okay, so we have made our first commit and our first push. Have people gotten there? Okay, great. So we can go to our history tab here in our RStudio interface, and we can see these commits. So my initial commit was to just make this repo. Then I added the test script. And then I added my R project. And so now when I go back to or when you go hopefully to your github.com repository, you will now see test.r here.
Courtney, I think it's if you're working on 2 monitors, we're not.
Oh my God. Okay.
Oh, wait, here we go. Okay. Yeah.
You will see test.r here in your workshop. Does everybody have that? No. Okay.
I do not have that.
Okay, did people push their commit?
I still can't push. It's just like stalling like it was for you.
Okay, sorry. I think what's happening is that it wants you to push your R project. So if you go to your Git tab and click the R project that's in there.
My R project is no longer in my Git tab. Oh, sorry, I see the project, but I don't see the R script.
Oh, because it's in you, because you committed it.
Oh, okay.
Mhm.
So I committed it. I pulled and pushed OK, but I didn't get that window pop up.
Window.
I'm sorry, I forget the steps that you just went through. The most recent thing that you did, the history. Yeah. when
Oh,
you did-
history. Okay, so here we have our Git tab and click on history. And we can see our history of our previous commits. Can
So
everyone-
I have a history tab. It's environment history connections Git.
Mhm.
When I click on Git, I don't see a history.
When you click on Git, you don't see history.
Oh, well, on mine, it's just a little clock. So.
Oh,
that's-
okay.
Yeah, sorry.
There you go. No worries. So we can see our commits here. And we can click on our commits and see what changes were made. This is my initial commit where I added a readme and a git ignore, which is what I did online. This is where we added our test script. And this is where I added my R project. So has everyone been able to push the R script to their github.com? If anyone's still stuck on that part, maybe send a chat to Kendall and Michaela and they can help you out. Okay. So if you're ready to move forward, give me a thumbs up. Okay, so Sharon, still working, Sierra, Simone, and Kaylin. Okay, so if people are still having issues, feel free to chime in and we can try to work through those.
Is anyone else having trouble with their GitHub online? I can't, my online GitHub is not loading anymore. Could just be my internet.
At first, I didn't see that my new script was in there, and I just clicked on my repository name again, and then it showed up.
Yeah, you might need to refresh like any other website too. But if we click on this test.r, we will see our R script here as well. We will see when the commit was made and the number of the commit, which we'll use later.
We can't see your online screen.
Great, so here we go. Okay. Sharon, were you able to get that up there? Pushed?
I finally did, but it's asking me to sign in. So.
Oh, okay. Yeah.
This is a good thing.
Okay, so we're going to now go back to our R project, and we're going to make a change in our R script that we just created. So our test.r script, we're going to add something else. we can say this is a new line. And we're also going to put back some of these exclamation points. And we're going to say, we're just gonna say R script. Not this is an R script. So make whatever changes you like to your little test script and save those changes. And now people will see in their Git tab here that we have our little M. So this means modified, right? And so we're gonna commit these changes because, yeah, we're just gonna commit them. And when we click on our staged and press commit, we're gonna see our diff pane come up. This was what we had before, and this is what we have now. Right, so I see that this is a new line. I see that I have more exclamation points, and I see that R script changed. Okay, so updated test R script. That's my commit message. You could write something maybe more helpful. And then we're going to commit it. And we can see that this one file changed. We had 3 insertions. So that was the line that I wrote, and the exclamation points. And then I had 2 deletions. So I took out some words, basically. Okay. And so now I can also see again that my local branch is ahead of the main branch, which is what's on github.com, by 1 commit. That's this commit right here. Okay. And so now we're going to push that as well. But first, pull. And it's going to tell me it's already up to date because there's no other changes. No one else is actually working on this repository, but maybe someone else was, in which case I want to pull before I make that push. Okay, and now I'm going to push.
I have a question.
Yes.
If I'm the only one working in the file, then I don't need to pull every time. It's just the push that is important.
Yes.
Okay.
Yes.
Just make sure I'm.
But it's a really good habit to get into, to just pull always and then push. Like,
okay,
you're gonna save yourself hassle later on if you are collaborating with people, to just get in that habit. And when your machine is working, the pull doesn't take a long time. It's like a quick, you know, and just, it's also good to just kind of check in with yourself. Like, okay, everything's up to date. Right, and so this is what a successful push message looks like. It's basically saying that the head, which is where I'm working, went to the main, which is my github.com repository.
Courtney, is it important that when you close that window, it'll be easier to see the difference, but in the upper left there, right under staged status and push, you have nothing. I have the name of my repo.
Oh, that's nice. You might have a newer version than me. You guys probably, you probably do, because I didn't necessarily do all the updates yesterday.
Like I could click on staged, like that's an option for me.
Oh, nice. Okay. So for me, I can do staged here and here.
I think that they've been the GitHub interface in our studio is actually relatively new. Like when I first started using GitHub, it was only command line. So I feel like they're often updating it and making it better. And I think there's a lot of things about it that are, you just get more information than in the command line, like showing those green and red, like what the changes are and stuff like that, which is great.
Thank you.
Yeah.
Would that be an option if you had, because I also have that, Sharon, I have my repo is showing up, and if I had multiple files within my repo, could I just click my repo and commit all of them at once?
Yes, so we will do that a little bit later if we're gonna have time to move over a existing folder structure that we have onto GitHub. We can commit a bunch of different files at once. We can say like, okay, add all of these scripts together. Click them all, put them all in one commit message and push them all. Was that your question kind of?
Yeah, thank you.
Okay, great. So also another cool part of, this is actually an R project feature, but this is also going to be part of the GitHub interface, is that you can see your files here and you can see your file structure. So now I see that I have this test.r and I have my README, which I can click, and I could edit this README as well. Right, shows up here, modified, all the things. What else is cool? So we have our history tab, which we went through. We have our commit tab. Commit and diff are going to show up together. We're going to see our diffs when we make a commit. Right, so these are our diffs. You can see here that I wrote, here is an edit. But if I were to just click diff, and I didn't want to commit, I just wanted to see what I did, I just can see the diff as well. So the commit and diff buttons here are actually doing pretty much the same thing functionally. Pull and push. We're not going to talk about rebasing, history, and then more. We have ignore, which we can either use through this button or we can use through our git ignore file, which we'll talk about. And we also have revert, and then we have an option for our shell, which gets us to our command line. These are branching here, this little function, which we're not going to go over branching today, but if you do get into branching, this is how you do it here. Is everybody on the same page where we have saved our test.r? We've pushed it, we've edited those changes. Is everybody there?
We have a couple folks. Well, Kaylin is still having trouble with her initial push, similar to you. It does, she can add commit messages, but it does that like long, slow thing when it won't push. And then someone else is having, if they click on the README, it doesn't show up on my Git tab, even though I can edit it. Do we know why?
Have you saved it?
I have not. Let me try that. There we go. Thank you.
You're welcome. So you can make as many changes as you want, but the Git is not going to know until you save it on your local machine. And so, yeah, and for whoever might be still struggling with the first push, we're about to have a 10 or 15-minute break here before we go into part 2, and so we'll help you with that. So let's do one more thing where we're going to talk about revert. So has everyone been able to edit their README with some pointless comment that they don't care about? And it's now showing up in their Git tab. Okay, great. So we're going to go to commit. And I do this all the time. I work on something and then I realize, you know what? I don't actually really care about this line of code. This really wasn't helpful. I'm not going to actually push or commit this. So I'm just going to revert or unstage all. We can use either. They have a little bit of a different meaning, but here we'll just talk about revert. So revert. I have decided I do not want to commit this change where I say here's an edit. So I'm just going to say revert, and this is going to say changes to the selected file will be lost, including your staged changes, which is what you've done by saving your file. Are you sure you want to continue? Yes, I do. And now, no longer in our Get tab, and this is an edit is no longer here, right? So it's going back to that last version.
So this would be used, Courtney, if you like were adding like to the README file, like maybe some piece of text that you thought was necessary, but then you're like, oh, okay, maybe I don't need to add that, but you had already saved the script. And so you're like, oh, I just want to undo that.
Exactly.
Okay.
Any changes you've made since the last time you saved, you can just go back. Cool. Is everybody on board with that? So let's go back to our outline and see where we're at.
So just one more question that we had from Courtney Courier. So she said that is committing deletions, is that the same as reverting?
I was just making a comment, like, that's cool. Like, instead of having to make another version where you delete a bunch of things, you can just revert it.
Yeah, definitely. I do it a lot, actually. Maybe I'm writing a lot of useless code, but I'm often realizing that, and that's nice because I can see in my diff screen, like, these are the changes I made. Do I want to commit them? Actually, no, they're not that helpful. I don't really want to commit them. I'm just going to revert.
It seems like it would be helpful if you don't want to drag your collaborators down a rabbit hole that was unproductive.
Exactly. Yeah, totally. Yep. And that's actually really a benefit over something like Google Drive, where once those changes are made, they're automatically saved and they're automatically in that version, right? So, okay. And so I think the only other thing we didn't get to was the get ignore. Let's see. Let's do get ignore when we come back. Just so we can get everybody making sure they have something pushed successfully and kind of on page. And then everything else we really got to. Any other questions before we take our break?
Robin had something happen where she says when she did the revert, it went back to 2 changes, I guess, instead of this one.
It went back to 2 changes. So, and did you save them both times?
I think I did. And I know I saved it when I did the, this is an edit one. I'm going to try it again, but it sort of leapfrog too.
Yeah. And so maybe if you didn't commit them, it will revert to anything.
Okay, I probably didn't commit.
Yeah.
Let me try that.
Okay. All right, so let's all come back around 10 till. Does that sound good? 10 till whatever hour you are in. And then we'll do the second half. And I can stay on, we can all stay on with anybody having some issues. Cool. See you all in a little bit.
Thank you.
Yeah. Courtney, I think Kaylin needs some help, but I think it might be easier if we look at Kaylin's screen.
Yeah, Kaylin, why don't you share your screen with us?
So I just had a really hilarious realization. I use 2 monitors because on Zoom it makes my original computer monitor go out, like black out. And what was happening is every time I tried to push, it was basically it was opening the dialog.
Great. So what we've done up to now is getting us set up to work in an R project with GitHub and interface with our studio. And we can do that with ourselves, like Fernanda's question about pulling, we're the only ones working on a repo. But the great thing about GitHub is that it really facilitates collaboration between people on scripts and makes that collaboration a lot easier. And so we'll want to think about some things that we can do to make that and to facilitate that. So we'll go here to part 2, working in a shared repository. And so one of the first things we want to think about is our permissions. So you probably all remember when you were making your repository a little while ago when it asked you to make something public versus private. So let's all go back to our repository.
You're not sharing your screen, Courtney. That's what I feel like I just repeat this all the time.
I love you. Okay, let's go back to our repository. Here we go. And let's click on it. So is everyone in their repository? All right, so let's go to our settings tab here. And this is where we can change our settings of the repository. So currently the repository is called this. You can do a lot of other stuff. You can include images, you can make a wiki, lots of things you can do. Issues, we'll talk a little bit about issues in this section as well. Merges, all of this. But if we scroll all the way down to the danger zone, this is where these things are kind of major changes that can be made. One of them being change repository visibility. So I think I had you all make your repository public, but let's change this to private. So we're gonna click change visibility. And normally when I am starting with something, I'm making it private because again, if something's public, anyone can clone it and use it. And oftentimes, you know, you're not really ready to share stuff kind of with the whole world yet, unless it's published or it's just something that's not that important. So let's make this private. There are some things that you lose with making things private, but it won't be private forever. And so when you're in the danger zone, in order to make changes, you have to do this typing thing where it's like, they make sure you really want to do this. So type in your name and the name of your repository. I understand, change this repository's visibility. Okay, it's gonna ask me password. And now I have a private repo. If you scroll down, you can now see this repository is currently private. Was everybody able to do that? Awesome. All right, so Kaylin.
Can you still share when it's private with certain collaborators?
Yep, we're doing that right now. So we will now go to the manage access, scroll up and manage our access. And so here we can invite collaborators. So we can see who has access. Right now it's a private repository, so only those with access can view it. And so we can either click manage here or we can click invite a collaborator. And you can also see that there are no collaborators with access currently. But I'm gonna invite Michaela, and she's gonna get access to this repository. Very excited about that. And so now we can see there is one person that has access to their repository, one invitation. And her invite is pending, so we'll see if she accepts me. What else is happening? Oh, yes, you can only invite people who you follow. So follow people on GitHub. As you can see, I follow Michaela Phillips, and that's why her name showed up as potential collaborator. So when you want to share stuff with someone, you need to get their GitHub ID, and you also need to be following them. And they might need to be following you too. Is that right, Michaela?
I don't know if you have to be following each other. I thought I accepted your thing, so.
if I tried to do this yesterday because I wasn't following you, if you're not following them and you start to type their name, they won't show up. So I think that that's how it does it. So we can see if she's accepted my invite. No. But this would allow Michaela to clone the repo to her machine and make changes to it and push and pull from.
I'll accept it. I thought I did.
From this repository. Okay, so that's kind of one of the best ways that you can work collaboratively is through this invite a collaborator. Let's see, you can also transfer ownership. So let's say you were working on a project for a while, but you moved to a new position or you're not working on it anymore and you just want to kind of hand it over to somebody else. This is how you can transfer ownership. Can be useful sometimes. Archiving, something where you don't want to delete it, but you don't really want it to be coming up on your main page anymore, and then deleting. So we'll delete this repository at the end of this workshop. You'll have to do the same, like typing in to confirm that you're going to delete. Those are all your danger zone options. So let's go back to manage access, and I don't know what's happening here. I'm still awaiting Michaela Phillips' response, but that's okay. I was gonna see if we can show how to.
I just accepted it. I had to find it in my email, which took a minute.
Okay, so now Michaela Phillips is the collaborator on this project. Okay, and I can manage their access here. I can remove their access, and I can also say the type of access that they are. Or no, this is just. Oh, okay. This is just to filter these things. And then, so now Michaela has the options to push and pull to this repository. Cool. All right, so any questions on that? All right, awesome. So we are going to think about our now local and global file structure. And so when we are working in R, is everyone seeing my R screen again now? Okay, great. So when we're working in R, a lot of times, and I initially would always have like a set working directory command where I'm setting my working directory on my local machine. Maybe I'm setting that to some folder where my data lives, or to my Dropbox or to my Google Drive. But when you think about sharing scripts with other people, you really don't want those types of information in your scripts, because what you want is someone to be able to pull down your repository and run that code in the same fashion. So if they have something that says read.csv, C users, Courtney's PC, like documents, like that's not going to get them anywhere. So what we want to think about when we're writing scripts for shared collaborations is having a really organized file structure where we have our scripts and our data. So, and everyone can pull from the same global sort of file structure. So let's make a new just folder in here in our WISE GitHub workshop test, where we call this data, right? So let's make a data folder in here. And in this data folder, let's put like an Excel file where we have some awesome data. Right, so like, just do whatever you want. Maybe in the right order. So let's save this as and I always save things as CSVs, but so now we have a folder called data and we have some data called data. In our repository. Okay, so let's go back to our test script. And let's say read.csv. And so now here, we're gonna say data sorry, let's call it something. More data. So now in our global environment, just like in any R analysis, we have this data file. Does everyone see that? And then in Git, what do we have? We have this new data folder. We've added this data folder with this amazing CSV of data. And, oh, I'm sorry, I'm putting this in my README. Let's not do that. Let's not put that in the README. Let's put that in the test.r. Thank you. Okay. Let's save the README without it. Something cool is going to happen now when I click this. It's just going to go away. No, it's not. Never mind. Oh, because I put it, never mind. But I can revert whatever changes were on the README because I didn't actually make any changes to the README. But test.r, I did make changes. And data, I added data. So let's just, in case you accidentally changed your README like I did, let's just revert that because that was stupid. And then now we have only changes to our test.r where we've pulled in our data and our data file and folder where we've added it, right? So we have our A here, add, and our M is modified. And so what I'm really trying to show here is that this is going to be whatever folder you make that's going to be on your local machine, but then you're going to push it to your github.com. And so you're going to have that same structure for anyone else pulling down your repository. They're now going to also have a folder called data and your file in there, right? And so they can run anything they want rather than having stuff being pulled from your Dropbox or whatever. Okay, so are people here with me? Let's push our new data structure. So let's commit it. And call whatever we want. Let's commit. It's gonna say 13 insertions, that's my data. 2 files changed, 1 deletion. I'm not really sure why it says 1 deletion, but that's okay. Pull, just get in the habit of pulling. It's gonna tell me everything's up to date because nothing changed. Right, and so let's push. Okay, so my head went to the main. So in my local repository, on my local machine, in this repository, I have a folder called data. And now on my global environment, on the other web page, I also now have a folder called data. Does everyone have this? And now, when someone clones this repository and they run this test.r, it's just going to say data and data, or whatever you call these things. And they're going to be able to run that exact script as well. So forget about setwd or however you usually do it in R, and think about working directory is your GitHub repository. Okay. So that's one really important part. And I usually also like to make a scripts folder. I think it's just a good practice to always have data and a scripts folder if you're working in a really R heavy thing, which most of us are because that's why we're here. So I'm going to put this test.r into my scripts folder that I've just created. Are people seeing this? Scripts, all that? Okay. So now what's going to happen? I got this, that the file was deleted or moved. Do I want to close it? Yes, I want to close it because I know I just moved it, right? And so what's showing up here, test.r was deleted. This is the D, delete. It was deleted from the main repository. So I'm going to commit that, but it was actually added here. And so this is renamed. It's actually just saying, okay, I just put test.r into scripts test.r. So it's pretty cool. It knows what you did and it's showing you that change in your repository. And if you want to commit that change, you can. But again, if you decide, actually, no, I want to keep that out of that folder, then just hit revert. But let's commit it because I like having a scripts folder. So move So that happened. There was no insertions or deletions. Something was just changed. So it was just moved, right?
Hey, Courtney, would you mind doing this command again?
Yeah. The creating the folder?
Yes.
Totally. Okay, so just like any other time you would create a folder on your local machine, on your desktop, just gonna go to your, wherever your, you can do this in RStudio, or you can do this in your file explorer, or you can do this in whatever. I can also, so when I'm here, I could say in files, I could say new folder. If you'd rather stay in your RStudio interface, that's fine. I often don't make a new folder here, but I could. Let's just say scripts 2. Right? But what I did was I just went into my Windows Explorer or whatever you want to call this and just said new folder, just like any other time you would do that. And because I'm in this version controlled project, that change is showing up in my RStudio pane, which is really cool. It's not in our file. It's just a folder that I made, but it shows up here because it was a change to that project. So I don't, although it's not showing up, my scripts 2 is not showing up actually, which is interesting. Does anyone know why that is? If you make a new folder through the files, it's not going to show up on your Git. I usually just make it in my Windows Explorer and then I add my new files there.
Can you
And
go over how you moved the script into the scripts folder? Did you just do that in File Explorer too, or was there?
I did, yeah.
Oh.
I just copied the test script over from, it was down here, and I just copied it into this folder. Just like any other time you would move a file. But GitHub is keeping track of all of these changes. So I can Control X, just move it back out. And now does everyone see this? Like R knows, or GitHub knows what I did. Now, actually, I took it back out. But I don't want to take it out. I want to keep it in. So I'm going to revert that. And now test.r was added. And why was test.r added? Oh, now I have it in both places. Does that make sense? Because I only deleted the movement. I didn't delete the add. So I could go back 2 commits and it would take it out of the scripts folder. Right, so this is just like GitHub keeping track of where your stuff is at. So it is a little bit tedious because anytime you're moving stuff around, GitHub and RStudio are gonna track that, and you're gonna either need to commit those changes or not. So sometimes it can get overwhelming if you're just moving a bunch of files like all over the place. You might have a pretty crazy, get staged pain. So think about that while you're trying to make changes to your new structure.
I have a quick question.
Mm-hmm.
What if you're working offline? Like, let's say you're, I don't know, on a bus or an airplane or something and doing all this stuff, being super productive, and then like you're not actually connected to your GitHub?
Yeah. You can make all your commits and stage them all offline, and then once you get back online, just push them all.
Oh, cool. Okay.
That's what I usually do.
Yeah.
I find that I work without internet more than I'd like, and I usually just make a bunch of commits so that I have notes for myself.
But if
so like your commits will save locally.
Yep.
Or the stagings.
Yep. All your commits will save locally, and they'll all be in your history before you push them and after you push them. But again, if you're working with someone else, pull when you have internet work, and then yeah.
That's scary. Yeah.
It's not too scary, and we'll go into and we'll make an example of what happens if you get a merge conflict.
I think often too, when you work with, like, at least in my limited experience working with someone else, I will each have our own branch, which we won't get into today because branches and forks are complicated, but we'll each be working on our own branch if we're working on it a lot, and then we'll bring those back together. So there are ways that you can kind of have like working on things at the same time. There's options for that.
Yeah, but you can still get merge conflicts from branching when you try to re-merge your branches too. So
definitely.
Yeah. So yeah, okay. And then finally, so we talked about the forget set working directory, and consider GitHub your working directory, and now get ignores are your friend. And so let's think about get ignores. Okay, so does everyone have this data file now? Data folder and data file in their github.com. Cool. So let's say that I want to share scripts with this person, or I want to share some part of project, but I don't want to share the data because maybe the data is not public yet or whatever. I don't want the data folder to get pushed up to my github.com. And I don't want to always have to like tell GitHub, okay, just don't commit that, right? So we're going to go into our get ignore file. Okay, so this is get ignore, and get ignore is named pretty aptly. It tells Git to ignore these things. So anything that's in here is not going to show up in your Git pane. It's not going to get tracked. And so because we chose an R flavored get ignore file, R already has some stuff that a lot of people just want Git to ignore, like your R history. You don't really want to be pushing R histories up to GitHub for someone else to like pull in your R history because that's kind of personal to your local machine, right? A lot of our data files are really big, and so they're going to clog up your push-pull. And so you just want to keep them on your local machine, potentially. Maybe you don't, but maybe you do.
And if you try to push something big, like a big data file to GitHub, it will get mad. Like it'll not be pleased about it.
Yeah, it can crash. So, and it can mess up your stuff. So you want to think about that. I often don't push my R projects at all. You don't have to, you can. But I find that like keeping my R project on my local machine makes sense. So if you want to just not push an R project at all, so this is R project user, but if you want to just not push R project at all, you can do the star and then .rproj. Okay. And then, so what we'll do here is we're gonna now tell, we're gonna tell gitignore that well, I guess we already pushed the data folder. We're gonna tell gitignore that we don't want the data folder pushed. So we're just gonna put that in there. Or we don't want the data folder tracked, right? So we don't really need GitHub to track any changes in this data folder. Okay, so we're gonna save that. We're gonna save our gitignore and should be coming up. No, why isn't our gitignore changed? Okay. That's weird. Okay. Normally it will pop up in my Git screen, but here it is. Okay, yay. All right, so there's my gitignore. So I've modified my gitignore. And I'm gonna commit that. And you can see here that, so. Okay, so this is a commit message telling myself that I'm updating my gitignore and I don't want it to push our projects or track changes to my data folder. Okay, and so I'm going to commit that and then I'm going to push it, or I'm going to pull and then I'm going to push it. So now my gitignore is updated. Did everyone get to do that to their gitignore?
So question, does this mean that everything that we did in the first part of this workshop, if you were just using Git to like store your data files and have it available, you know, as your example for a publication or something, would that mean that you would sort of like ignore a lot of the push, pull, commit things that we did in the first part of the workshop, and you would just add those folders to your git ignore and sync, and that's it?
If you want to have your data on your GitHub repository, then you don't need to add this data to the git ignore. I personally oftentimes don't push and pull large data files between my local machine and my github.com, just because it can clog the push pull, and they're often hard to keep track of the changes because they're really big data files. Like for example, if you had sequencing data or something like that, you're not really gonna want to push and pull between. So you might get those to your GitHub in a different way. Like you might directly upload them online rather than pushing and pulling them multiple times from your local machine. I don't know if I'm answering your question, but you don't have to do this in the git ignore. I'm just giving an example.
Okay, thanks. I think that definitely helps. I think it'll become clear as I continue to practice with this. Thank you.
Okay, awesome. So let's see what the git ignore does now. So we're gonna go back into our data folder that we made, and we're gonna pull up that data CSV in Excel. And we're gonna add some more data. Okay. And we're gonna save it. Okay. Save it a million times. And it didn't work. Because why didn't it work? Maybe I need a star. So as you can see, Git is still tracking the changes to my data folder, and I don't want that. So something that I typed in my git ignore didn't work. And maybe I need this. What's happening here? Okay. Michaela, do you know how to do this? I just did this yesterday and I don't know why it's not working.
It's not working for your data folder?
Mm-mm.
And you tried with the star?
Yeah. Oh, probably because I need to push it. Yeah. Okay. Doo-doo. Okay, so let's try that.
You might have to put the star backslash, but try this first.
Sorry, guys. Update. Ignore. Okay, that worked. So the star is what we want. Sorry about that. So now I'm saying anything in this data folder, don't track. Okay, and now as we can see, that staged change that I made to the data isn't there anymore because now Git knows to ignore that whole folder. And so for example, I run models in BRMS, which have really large outputs, and they're saved in our data. And so whenever I'm running my scripts, I just put all those outputs into a folder, which I can pull from later on in my post-analysis scripts, but I don't push that output folder back and forth because that output folder has a lot of memory taken up. And so that just stays on my local machine. And so I have something in my git ignore that just says, ignore this whole output folder. And that's really helpful with working with other collaborators too, because they'll pull down your scripts and your data, and they can run your code, but then they can save their output to their local machine as well. Okay, questions?
We have a question from Hannah.
Totally. Comment notes to yourself in the gitignore file. Totally. It's just like an R file. So you can say like, don't want to data folder. Right. And you can like, you know, I don't know what day it is, but you can like go back and you can always change your gitignore file anytime. Maybe you want to start now tracking changes to your data folder later on. Cool. Also, you can do that in your commit messages when you're telling yourself what you want to do. Okay, so any other questions about gitignore? It doesn't always make sense initially why it would be useful, but as you continue to use GitHub, and especially in a collaborative way, you will find many uses for it. Okay. So we've done forget set working directory, gitignores are your friend. Let's move on to issues and assignments. So when you're working in a shared GitHub repository, there's a really cool functionality called issues and assigning issues. So this is actually not through the RStudio interface, but I did want to just go over it because I think it's a cool function. So if everyone wants to go back to their repository on their github.com, and I would recommend adding, hopefully everyone got to add a collaborator when we did the share permissions. If not, I'll just show you kind of what that looks like. So welcome to issues. So we're gonna go, so here's code, right? Here's our folder structure. And next is issues. And so.
Can I ask a quick question, Courtney?
Uh-huh.
Back on code.
Mm-hmm.
Does it, what does it mean that on your screen, the bottom feature there that says 1 hour ago is Wise GitHub workshop.rproj? I don't have that. I just have data scripts, gitignore, and readme.
Yeah, you might not have pushed your R project, which is okay.
Okay.
You don't have to.
The R project was the first thing that we made. And in a lot of cases, you might not want, if you're working collaboratively, you might not want to push your R project just because your collaborators will have their own project.
And that's why I actually put that star.rproj in our gitignore file. Normally I do first before I don't normally push my R project. I just did because my machine was being weird and I was trying to get it to work.
Oh, okay.
You can think of an R, like a .rproj file as like the container of your work. So it doesn't really have any important information, like it contains your scripts and all that information. At least that's how I think of it. Could be.
Right, so your R project is the thing that's allowing your RStudio to interface between GitHub and RStudio, right? So remember how we did that create new project version control? That is kind of the vehicle that's going to allow RStudio to talk with GitHub. But you don't need to push it to you really probably just want to keep it on your local machine. Okay, so let's go back to issues. Let's create a new issue. And let's say readme not informative. The readme for this repo needs more information. Or whatever. actually, normally I would write something about my R script, right? So let's submit this issue. Let's do a new issue and say test.r bonking, like can't load data.csv, right? And I can't probably because I just put it in my get ignore. And we can even leave a comment and say like line 42 or something of the code so that people can actually get to where you're talking about. So if I go into scripts, test.r, and I'll say like line 5, right? I'm gonna go back to my issues and I'm gonna say test.r bonking, line 5, right? And so this is just keeping a track of issues that might be happening with your code or things that aren't working. And you can use issues to keep track of stuff for yourself that you need to fix. But you can also assign them to your people, your other collaborators. And so I can assign these issues, and I'm going to assign this to Michaela to figure out. Okay.
Check. I think you just check me and
Yeah,
it's
you
good.
just check it.
You also can, if you're working in an R package and there's something wrong with it and you know it's not a you problem, then you go onto the GitHub page and you make an issue and be like, hey, this command doesn't, this function doesn't work. And that's how the package developers will know to fix things. I personally, I do use issues for myself to be like, okay, these things are, I've made it halfway through this function and this script and these things are broken and it doesn't work.
Yeah.
This is why, I think.
Yeah. And it's a really nice way to just keep track of issues in your code that are like really well described, and you can go back and forth to them. And then when something is fixed, you're like, actually, I uploaded new version of data.csv, and that fixed the problem. Okay, and so I'm going to comment that, but I'm also going to close the issue. And so I closed this issue. So this issue is now fixed, right? But let's say actually a week later, someone else comes back to it and they're like, oh no, that didn't fix it. They can reopen it, right? So we can reopen this issue and keep it going. And then only when it's really old, you can delete it. But it's good to keep them around so you can see what things were fixed. This is a really nice way to keep your collaborators involved and kind of assign different issues that might be going on. Like I'm currently working on a data synthesis with a bunch of people from Niwot Ridge, LTER. We have a shared repository and I have issues with the code where I'm pulling in data from other people's sites and it's not, you know, something seems wrong or whatever. So instead of me sending them an email being like, in line, I just put it in here, right? And I'm assigning them this issue. Okay, do collabs get pinged when you create? Yes, they do. And so as long as you assign it to them, they will get an email or however their settings are set up for GitHub, they will get notification that they were assigned this issue. Cool. Any questions on that? Okay, so we'll do one of the last kind of most important things about.
There was a question. Do collabs get pinged when you create an issue?
Yeah, I don't
know if you saw that one. Okay, I didn't hear you.
That one. Cool. Okay, so we'll do merge conflicts. So we are going to practice. We've been alluding to this for a while, but we're going to practice and we're going to do it and we're going to move through a merge conflict. So we're going to practice creating and fixing a merge conflict with ourselves. So let's go. And because, you know, we're not actually collaborating with other people in this repository yet. We're just gonna kind of fake it and do it with ourselves, but imagine that this was another person doing this on their machine. So if everyone goes back to their GitHub page, and let's go to their scripts folder and test.r. And if you remember, you can edit stuff directly on GitHub. So we're gonna edit this file. And we're just gonna take out this data, or actually, no, let's not do that. Let's take out this. This is a new line. Take out something, change something, whatever in your test.r script. And actually, one of the nicest things on when you do it directly on github.com is it just makes this commit for you. So it says update test.r, which is what I did. You can add more descriptions. Delete. Delete. But that will also show up in my diff, so I probably don't need that. So I'm going to commit this change directly. And this is my new test.r script. Has everyone made that change? Okay. So let's go back down to our local machine. Let's go back to our studio. And let's open our test.r script. As you will see, the line that I deleted is still there because I have not pulled. If I were to pull before I made changes, my test.r would have gotten updated. But I forgot. And so I just kept going. And because I love this line, I'm just going to keep writing on it. Okay. And so now I've saved it. And my lovely Git and GitHub has tracked those changes here. And I just am not remembering to pull, and I'm just gonna commit that, adding more to my favorite line. And I can do this. This is allowed. And I'm gonna push this change now. Is everybody with me here? Has everyone made a change on their github.com and now they're making a change on their local machine? Okay, so we're gonna try to push this change. And it was rejected, it failed, okay? So you can see updates were rejected because this remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You might want to first integrate the remote changes. Blah, blah, blah. Git pull before pushing again. And so we are going to pull. And now we are going to see content conflict. Merge conflict in scripts, test.r. Are people seeing this on their screens? Okay, great. So I'm gonna close this out and you're gonna get the lovely UU. That's the code for merge conflict. I don't actually know why. Unmerged. That's what that stands for. And you'll see these little arrows. That's gonna tell you this is where your merge conflict is. You can see it in your diff screen and you can see it in your now conflicted document. And so what your conflicted document has is the head where you have the changes you made versus the version that was online, which was a blank line. And so now you just have to decide what is the correct version. Save that and commit it. It's not always as simple as one line, right? Which is makes sometimes fixing merge conflicts challenging. There's a lot of changes in the code and you haven't pulled. And sometimes there will be a lot of merge conflicts. In one document, there could be many. But right now we only have one. And so we're gonna remove, remember that these are always gonna show you where the conflict is in between these two arrow lines. So we're just gonna take that out, I'm gonna take this out, and this is gonna be the version of the file that I want. Okay. And now it's going to be modified, just like anything else. And what I'm going to tell myself here is that I am fixing the merge conflict. And I'm going to push that. Hope it works. And it did. Okay, so it's not that scary. Sometimes it's way more scary than that. But you can fix merge conflicts on your machine. And anyone you're working with can also fix the merge conflict on their machine. But whoever encounters the merge conflict has to deal with it. And they have to decide what is the correct version of the file, right? Sometimes that's easy to figure out, and sometimes that's not as easy to figure out. So do people feel like they understand at least what would cause a merge conflict and maybe how to go about fixing it? And do people have questions?
I have a question, Courtney.
Yeah.
So what if your collaborator, like, say you guys are working on the same script, either at the same time your collaborator is working a little bit faster than you, and they made a change, like on that, they deleted that line 3, and that's like what really needs to be deleted, but you are saying like, you don't know that that needs to be deleted. So how do you fix that merge conflict if like the change before you is actually the correct change? Does that make sense?
You can revert the changes you made, or you can just go through and keep whatever you think is correct. It's going to show you both the changes that you made and the changes that whoever else made next to each other, always in between those lines of the arrows.
So it will show what the other person changed.
Yes.
That was my question.
Yeah, and so you always can just kind of choose between the two. Maybe, but maybe you don't know. And so maybe you need to contact your collaborator, or maybe you need to just make a decision, or maybe you need to do the nuclear option, which is the last thing that I guess we'll go over, which is something that I've done and it happens. And sometimes your merge conflict is just really messy and you don't know what happened. It's just too much to deal with. And so that's when you can kind of just scrap everything and start it over. And so we can go to, I found a little kind of comic about this. So burn it all down. This is highly inelegant but effective technique for disaster recovery. It has been immortalized in a comic, so it must be okay. This comic says, this is Git, it tracks collaborative work on projects through beautiful distributed graph theory. Cool, how do we use it? No idea, just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project and download a fresh copy. So this is what I call the nuclear option and what Sarah, my advisor, calls the nuclear option. But basic idea, commit early and often, pull things, blah, blah, blah. But if you don't, maybe sometimes we just have to scrap it and start it over. And so we'll practice doing that now with our repository. So let's just say that we have a really just bad merge conflict and we just kind of don't want to deal with it. We just kind of want to start over. So we're going to save, we're going to take this, our repo that we love and have been working on, and we're just going to move it somewhere that Git's not tracking it, right? So let's just copy or cut, and let's just move it to our desktop for now. Don't look at my desktop, it's super messy. Oh, okay, it's in, it's probably because it's in R. So let's just close our R. Don't save. And let's just move it somewhere else. Where Git's not tracking it, but we know it's there. And maybe we'll even name it something else like backup, right? Maybe we'll spell backup right. Okay. And then what are we gonna do? Like, does anybody know what we do now? Like, this is still here, right? Sorry, just delete the repo on GitHub. Is it that easy?
So you can clone? Okay.
Yeah, exactly. You would just free clone it. So we don't even need to delete it, right? We actually want what's on this version. What we don't want is what we accidentally messed up on our local machine and forgot to pull. Okay, so this is actually what we want. This is what our collaborators did here on github.com. They made all these changes. We worked on our script and forgot to pull and then messed everything up. And so actually what we're gonna do is just move our repository somewhere else on our machine and just redo this exact step that we did in the beginning, right? So we're just gonna make a new R project. Again, highly inelegant, not your number one go-to step, but in case of emergency and you just kind of can't figure out what's going on, just do it again, right? And so file, new project. Let's save that. Right, so now it's telling me that this R project doesn't exist, right? And it doesn't exist because I moved it, which is good. That's what I want, because now I'm making another one. Okay, so closing out that project.
So that's assuming that what your collaborators did, you want to save, and what you did, you don't want to save.
Yes. But oftentimes, whoever kind of gets there first is, if you're having a bad merge conflict, it's going to just sort of go in order of operations, like whoever made those commits first, whoever pushed those changes first. It's going to be easier to just pull those back down and then start from there. Or you can go through the documents with the merge conflicts and change all of the conflicts individually. But that can get really tedious sometimes and it won't always be clear, especially if there's like big changes to like a CSV, like maybe they added a bunch more data and you didn't pull down that CSV, and then and you were running something with that data file or whatever. Does that make sense? Sometimes it's not as easy as just looking at 2 lines of code and saying, okay, I want to keep this line and not this line. Sometimes it's a little harder. And yeah, you'll probably run into it, but hopefully you don't run into it that much. Oftentimes collaborators aren't working on the exact same thing all that often at the same time. So let's do a new project. No. And let's do this again. Do it again, create our new project like we did before. And now everything that was in there is going to come back on our machine. Okay. And here we are. So we can go back into, so now we have this backup version on the desktop. Where that was my changes. And I can pull up that script or whatever version of that script that I had, and I can look at it and see how it's different from the actual most updated or most correct version, which is now back in my Git folder where I put it. Right, and eventually once you've kind of made this happy in the way that you want it, you'll just delete that backup one. Or not, maybe you'll forget, but you don't really need it, right? So this is where you want to be working actively. So that's kind of worst case scenario. Yeah, go ahead.
I was just going to say, sometimes I'll have 2 repos for one project, like one research project, and the first one will be like exploratory stuff, and then I'll get to a point where I kind of know more what I want to do, and I'll just be like, you know what, I just want a fresh start, and I'll make a new repo and a new package and go from there. So I think that depends like how you like to organize things in your brain.
So there's a lot of stuff we didn't get to today, but I'm glad we got to a lot of the main stuff that I wanted to go over. If people want to stay on and work on moving over their existing projects to a GitHub folder, I'm happy to stay on and help people with that. And we have about 5 more minutes if there's any other burning questions that people have. Oh, and let's do the post.
Yeah, I'm going to put the post-workshop survey in the chat. And it would be great if folks filled it out. I think we'll also send it out in our email after with the debrief. I'm just pulling up the link.
So in the follow-up email, we'll send out this recording as well. So hopefully you can, if you feel like you missed a step along the way, you can go back and watch this.
Yeah, and I'll stop the recording now and stop sharing my screen.